This is the 11th and the final video on in AS Maths for differentiation. In this video we're going to do some problem solving using all the skills that we've seen so far. Quite often these problems are called optimisation problems because we're looking at problems where there's some form of constraint, and what we're looking for is the optimum output. What's the best we could hope to get? So the best might mean looking for the maximum of a situation, or it might involve looking for the minimum of a situation. So just by the language that I'm using, you can tell. So maximum, minimum. These problems involve differentiation. So just to give an example, if I have a certain amount of material, if this is the only cardboard that I'm allowed to use, and I want to make a box that's going to hold the most amount of the biggest volume possible, considering this is all I'm allowed to use, well, what dimension should my box be? How wide should it be? How tall should it be? And we can solve those sorts of problems using differentiation. So we're going to look at 3 examples. This is the first one. So we have a cylindrical can with volume 16 pi centimetres cubed, and it's to be made from a thin sheet of metal. I want to find what's the minimum surface area of metal needed. Okay, so this is quite a common sort of problem. Obviously, if I'm in manufacturing and I want to try and make sure that I waste as little material as possible while still having a can that holds all the volume that's required, then this is the sort of problem that I'm going to need to solve. So surface area. I want the minimum surface area of this can. So it's a cylinder. Let's talk about the surface area of a cylinder. You should know this from GCSE, but I'll recap it very quickly. If I've got a cylinder and I want to know the surface area of this cylinder, I've got the circle on the top, the circle on the bottom. So the area of those 2 circles, well, the area of one of them would be pi r squared. So both of them would be 2 pi r squared. What about the area of the rectangle that wraps around them? Well, that's going to be the circumference of the circle across the top there, times by the height. So the circumference is 2 pi r and multiplied by the height. Okay, so I want to know the minimum of this. Now, I've got a bit of a problem at the moment, is that I know to find the minimum I can differentiate. But what am I differentiating with respect to? Because I've got 2 things that I could possibly change here. I've got the radius that changes, and I've got the height that could change. I could have my cylinders at different heights and at different radiuses. So, radii. So what am I going to differentiating with respect to? So that's where this additional piece of information comes in. This is the constraint in this problem. So I'm told that the volume is equal to 16 pi. So how do we work out the volume of a cylinder? Well, it's the area, the cross-sectional area, which is a circle, times by the height. And I'm told the volume must be 16 pi. So straight away I can start to simplify this a little bit. The pi's will cancel out, and I'll get r squared h is equal to 16. So from this I could rearrange this, make h the subject, and I could say, okay, well that means that the h has to be, the height of my cylinder must be 16 divided by whatever the radius I pick squared. And by writing the height of my cylinder in terms of the radius, it allows me to replace it here. So I'm going to substitute 16 over r squared instead of the height in my area formula. What that allows me to do is, well, first of all I can simplify this a little bit. 32 pi. Now, I could write over r. However, to get the minimum, I'm going to differentiate this with respect to the radius. So rather than writing it on the bottom there, I'm going to write it here as a power of -1 just to help me differentiate it. Okay, let's look for our minimum. So we're going to differentiate a with respect to r, and when I do that, I get 4 pi r. This is going to give me, so the minus will come to the front, minus 32 pi. This will be minus 2 now the power, will be minus 2, which is the same thing as saying over r squared. So let me just do that a little bit more slowly. Taking 1 away from the power here will be r to the power minus 2. But I know I'm going to have to solve an equation in a minute, so actually I'm writing that like that. Right, so this is my dA by dr, and I want to know the minimum, so I know that that is going to equal 0 when there is a minimum. So here's my equation. So if I take the 32 pi over r squared to the right hand side, I'm going to do a couple of steps. I'm going to multiply by the r squared, so that's going to give me an r cubed up here. I'm going to divide by the pi as well. I'm going to cancel the pi from both sides. So cancelling the pi, move the r squared up here. Divide by the 4. And cube root. So r is going to be 2 centimetres. So, I know the radius of my cylinder. And based on that, I can now go back and work out the height of my cylinder. Because if I remember correctly, I've rubbed it out now, but if I remember correctly, the height of my cylinder was equal to 16 divided by the radius squared. So when the radius is 2, 16 over 2 squared is 4. So, both of those in centimetres. In this problem then, where I have the volume must be 16 pi centimetres cubed, by using differentiation I found that if I make the radius 2 centimetres and the height 4 centimetres, then that gives me this volume, and it will make sure that I've used the minimum amount of metal to do so. So the least amount of waste, or the least cost. Let's have a look at another problem. This one. So it says, a large tank in the shape of a cuboid is to be made from 54 metres squared of sheet metal. The tank has horizontal base and no top. Okay, so there's no top on top of this tank. The height of the tank is x metres. The two opposite vertical faces are squares. Part A, show the volume of the tank is given by this equation. Okay, right, there's quite a lot of information in this question. We'll deal with part B and part C later. There's quite a lot of information in this problem, so I'm just going to draw a little diagram to help me visualise what's going on. So, the tank is a cuboid, and it says the height of the tank is x metres, so this is x. And actually it says two of the opposite vertical faces are squares. So actually I've drawn my diagram a bit off because this should be a square, not a rectangle, but that's okay. Okay, right, it doesn't tell me anything about the depth of my cuboid. So I'm going to call it y. I don't know what it is, so I'm going to call it y. Right, I know that it's to be made from 54 metres squared. So that's the surface area here. I know it's the surface area. I mean, look at the units there, metres squared. So we're talking about area here. So that means that when I work out the surface area of all of these 5 faces because there's no top, it should add up to 54. So let's do that. So on the front, let me write down A equals, so I've got an x squared here and I've got an x squared on the back, so that's 2x squared. On the side here, the area of this is going to be x, y. I will also have another x, y on this side, and the area of the base is going to be x, y as well. So I'm going to have 3x, y. And that's it. So this side, this face, and this face is this. Then 1, 2, 3 xy's. And that's got to equal 54. Okay, right, the volume. So the volume, well, that's going to be x squared times y. So what I want to do is I want to try and replace this y using the information I have within here. So let me rearrange this and make y the subject, and then I can place it in here. So, rearranging here, I will have 3xy equals 54 minus 2x squared. Divide by the 3x, so I will get y equals 54 over 3x minus 2x squared divided by the 3x. So if I was to write that like that, we can get a bit of simplification here before I do any substitution. First of all, the x there is going to cancel with that there, and also actually 54 divided by 3 is 18, so I could write this as 18 over x. Okay, so I've got y as the subject. I can now substitute this into my volume formula. So the volume is equal to x squared multiplied by 18 over x minus 2/3 x. Which will give me, so this is going to cancel out and just give me 18x, and over here that's going to give me a 2/3 x cubed. And let me just go back and check. I think that's what it asked me to do. 18x minus 2/3 x cubed. Yeah, there we go. Right, so that's part A done. Part A of these questions will always be, you're going to write down an equation. In this case, we're talking about volume and surface area. So you're going to write down an equation for both. You're going to rearrange one of them, substitute it into the other one. That's always the first part of these questions. The second part is now saying, given that x can vary, use differentiation to find the maximum or the minimum. So let's differentiate that. So dv by dx would be 18 minus 2x squared. So that's got to equal 0 when I have a maximum or a minimum. Rearranging this, so 2x squared equals 18, x squared is 9. So x would equal plus or minus 3. However, in this case, in the context of this question, it doesn't really make sense to have a width of my cuboid as minus 3. So it's plus 3. And part C. given that x can vary, use differentiation to find the... Oh, okay, right, I'm glad I just reread that question because I've not finished it. I found out the value of x when there is a maximum or minimum, but I've not found out the corresponding value of the actual... I've not answered the question. I've not found the value of v. So, now I've got x is 3, I need to substitute that into my volume. So 18 times 3 minus 2/3 of 3 cubed, which is 54 minus 18, which is 36. Yeah. Okay, so please don't make the mistake that I almost made there. Read the question carefully, double check. It's asked for the value of v, not the value of x. I need the value of x though to get it. Okay. Part C, justify that what I found is a maximum. Because obviously when x is 3, that could be a maximum or a minimum. So if I want to justify, if I want to show that it is a maximum, then that means that d2v by dx squared, that should be negative if it's a maximum. So let's work this out and check. So we're going to differentiate. So this is going to give me, that's going to disappear, and I'll get minus 4x. So d2v minus 4x. And when x is 3, I get minus 4 times 3 is minus 12, which is less than 0. Therefore, it is a maximum.